Hello, today's lecture we want to continue a little bit into MATLAB, and what I want to look at specifically is I want to look at the plot command. So one of the things, I've talked a lot about how there are a lot of aspects of MATLAB that are really maybe better done in other software or other programming languages. But one of the things that is a real strength of MATLAB is its ability to plot data in just a number of different ways. So this is just kind of a summary of all the possible, things that you can do with plotting in MATLAB. MATLAB basically creates a plot, saves it as a figure. We have talked before in class about how you can use the command hold on to keep the figure in memory and plot any additional figures directly over that. We have not yet talked about subplot, nor have we talked about some of the specific commands within the plot command. And finally, MATLAB has the ability to do both two-dimensional and three-dimensional plots. And in three-dimensional plots, it can plot as a contour plot, which is something similar to what you might see on a geographic map with spatial contours. It can plot as a mesh, which is sort of like a three-dimensional mesh. It can plot a surface. It can actually plot XYZ coordinates. And so there's a lot of options that you have with MATLAB. So let's bring up MATLAB, and I've gone in and I've typed help plot here, and particularly we're going to look initially at just the first couple of options. So first of all, MATLAB won't plot anything that you don't have stored in an array. And so let's look at this line where we have plot y. Basically, plot y is going to plot the columns of y versus its index. So, for example, if you have an array that has 300 elements, then and you call that array y, and then you say plot y, it's basically going to plot all 300 points, and the x-axis is going to be 1 to 300. So first of all, MATLAB will not, when you just plot the variable and you don't give it an x-axis, MATLAB basically just assumes you're going from point 1 to point 300. And so it won't, first of all, it won't start at 0, it'll start at 1. And so that's going to look kind of awkward. And secondly, the x-axis numbers just correspond to the point in the array. So if you have a 300-point array, you'll get 300 points if you use plot y. If you have a 1,000-point array, you'll get 1,000 points if you use plot y. So as an alternative to that, you can actually tell MATLAB what the x-axis is supposed to be. So the first thing to bring up is that the dimensions of the x-axis that you give it and the dimension of the array y has to be the same. So let's suppose we do have our 300-point array, and let's suppose each point in the array corresponds to time from 0 to 150 seconds in increments of half seconds. So one option is if you know what your array elements correspond to, you can set up an array that sort of converts them from the index number on the array to time in seconds or distance in meters or whatever the x-axis is actually really supposed to physically correspond to. But you have to actually set that up in MATLAB. So you have to define an array x that has the same dimension as the array I and y and represents something physical. So you can see if x or y is a matrix, then the vector is plotted versus rows or columns of the matrix, whichever line is up. If x is a scalar and y is a vector, then basically it's going to create disconnected line objects that are created and plotted at discrete points vertically at point x. So just depending on how x and y are defined, you'll get different kinds of plots. Plot y would just plot, obviously, y. Now, if y is a complex number, it's going to give you a complex part. So you have to, so basically it's going to plot real of y versus imaginary of y. So you're going to get some odd looking plots. So if you're only wanting, say, the magnitude of the complex number before you plot, you might want to tell it to plot the magnitude. All right, so you have several options within the plot command. One of the first, and so in that case, the syntax looks like plot xy and then s, where s is some character string that can be made up from any or all of these columns below. So you can choose the color of the particular variable, and this is particularly useful if you're trying to plot more than one thing on one graph. You can choose what the symbol looks like on the plot, so you can have different symbols, and these are the commands that correspond with each symbol. You can make your line solid, which is the default. You can make it dotted, you can make it dash dot, you can make it dashed. So these are some of the options that you have to control how MATLAB actually plots your line. So for example, if you, in your character stream, tell it to plot, and then for your S, you have apostrophe C plus and colon, then basically that's going to plot in the color cyan. Each point will be plotted with a plus sign, and then the colon says that that will be a dotted line. So you have quite a bit of control. You can list multiple plots. So you can have, for example, x1, y1, s1, x2, y2, s2. Here the x's and y's would be vectors or matrices, and the strings would be the string corresponding with that particular matrix. So as you can see, this would be a possible alternative to using the hold on command. If you look at this example, basically you plot the x and y versus one another, and then you have y dash, which would be yellow, and the dash would be solid. And then if you have xy and then you have go, then basically that would be little green circles. So see the G and the O. So at each point you would get a little green circle. So this plot would correspond to a yellow line, a yellow dashed line with, or a yellow solid line. Let's see, yeah, yellow solid line with little green circles. So lots of options in the plot command. So you can also create plots in using other commands. So we'll get to some of those, including the subplot. But let's look just for a moment at what some of these things mean. So grid, if we look at grid, that basically is going to add grid lines. So we can say grid on, we can say grid off. That's going to put some background grid lines. If we say X grid, Y grid, Z grid, then that will create a grid on one of the axes. If it's a polar plot, then the grid will set a theta and R parameter. So that's what that is. Title basically adds text at the top of the current axis. So if you have title, text, property 1, property 2, and so on, you basically add a title to the specific axis. If you want to label your axes, you can use X label and Y label. So X label basically adds text right by the x-axis, and Y label adds text right by the y-axis. And so basically MATLAB is going to put a plot kind of in your working memory, and when that plot's in your working memory, just kind of like an active plot, you can then come in literally after the fact and add X label, Y label, text, etc., and MATLAB will alter the graph that's currently your working figure. If you want to see your graph, you can come up here to Window, and if there were a graph that was sort of being actively stored, you would see that as figure 1, figure 2, etc. You can also save and name graphs. So let's go back and look at some of the other things. So here are some of the things we talked about: grid, title, X label, Y label. Let's look and see what set does. So set, so if we come back up, set can be used for a number of things. It's basically used to define object properties for a graphics object. So H is some vector, and it includes sort of like the values for all the objects that are present in H. So I don't use set very often. I haven't seen it used set very often in much of the MATLAB code that I've written or reviewed, but it is something that will allow you to specify certain properties for certain things that are being plotted. So if we look here, here are some line and point characteristics. So we kind of went over this on the help file within MATLAB, but the nice thing here is that you've got it actually shown on a slide that you can refer to. So this just gives you some of the different symbols all put in one place in one table. So that's just for your personal use. Okay, you can also use upper and lowercase symbols and some mathematical symbols. So these are just symbols and the syntax. So in other words, if you want to use the symbol alpha, in fact, all the Greek letters, then the syntax there is \alpha. The syntax for beta is \beta, and so on. There's uppercase. All you do there is capitalize the first letter of the Greek alphabet. And then there are numerous mathematical symbols that you can use as well. And this is the syntax to create one of these mathematical symbols. Now, as you know, there is logic in MATLAB with like logic statements with things have to be less than or equal to. That's not the same. This is just going to create a symbol that'll show up on the screen. All right, so we want to look at some examples in the next lecture. I'm going to stop here and shut the video down because I know this is much easier to take in small quantities. So the next video, we'll look at some examples of 2D plots.